Welcome to the React 30 Minutes Crash Course. In this course, we'll cover the basics of React, a popular JavaScript library for building user interfaces. The aim of this course is to guide you through the fundamental concepts and get you up to speed in no time. So let's dive in. You'll need to have Node.js and NPM installed on your system to run a React app. If you don't have them installed, you can download and install Node.js from the official website. For editing the code, I'll be making use of Visual Studio Code, but you can use any code editor of your choice. If you prefer not to install React on your system, but still want to explore using it, you can utilize the website codesandbox.io to create and run the React app. We'll begin by installing React app. We will be using Vite build tool to install React app in our system. This will help us set up basic development environment. It is very simple to do it. We'll head to the guide page of the Vite and run the following command in the terminal. Let me copy this and open up the terminal. I'll navigate to the desktop where I want my project to be installed. When I run this command, it will first ask me for the project name. I'll enter my React app. Feel free to enter any name you want for the project. Next, it will ask me to select the framework, so I'll choose React. Next, it will ask me to select variant like TypeScript or JavaScript. For this tutorial, I'll select JavaScript. Once this is done, I can simply navigate to the project folder and install and run the project. So let's do that. This will take some time. Now I'll run the application. Let's open up the URL. By default, it will be running on port 5173. This is the default page which has Vite and React logo. It also contains a count button. If you click this button, the count will increase. I'll be running the server from within VS Code, so let me just Ctrl+C to terminate the server currently running. Let's open up the React folder in VS Code by simply dragging the folder. Before we start making changes to this folder, I'll just walk you through the folder structure. It contains an index.html file, the entry point that is responsible for loading all necessary files. This file contains the root element with id equal to root. This is where our React application will be rendered. We have a public folder that contains static assets like images and favicons. src folder contains the source code of the React application. This is where we will create our components. It also contains a few CSS files. Main.jsx is the entry point script that renders the root component app. App.jsx is the entry point component of the application where you'll find the code for the default page that is being displayed with the counter button. We also have package.json for the configuration of npm packages and scripts along with Vite configuration file. Let's open the app.jsx file again. If you're wondering how this file content shows up as the default page, let me open the index.html file again. We see the root ID here, and in the main.jsx, we have this code which basically gets the root ID and renders the app component in an HTML-like syntax. Let's open the app.jsx file. This file looks a little weird, to be honest, because it is a JavaScript file, but we also see HTML code written in it. Usually, code like this should result in an error, but the reason why this works is because of JSX. JSX stands for JavaScript XML, which allows you to write HTML-like code within JavaScript files. This code is then transpiled into regular JavaScript during the build process. JSX helps us declare and use components. I have mentioned components a few times, but we haven't discussed components. So first, let's look at what components are in React. Components are one of the core concepts of React. They are the base on which we build user interfaces. You can imagine them to be the reusable UI elements for our app. Consider a web application layout. An example of UI component could be a navbar component, or a sidebar component, or say footer. In essence, a React application is composed of various components working with each other. So let's look at how to create and use React components. In React, we create a component using functions. The name of the component in React should start with uppercase letter. Also, this function returns some markup, mostly in the form of JSX. Let's rewrite the app.jsx file. I'll delete all the code here and rewrite the code. So, I'll have a function app with first letter in uppercase. For markup, I'll simply add an h1 tag which contains hello world message. Let's also export this. I'll open a new terminal and run the server to check if the changes are reflecting in the browser. As you can see, the changes are reflecting on the browser. If you don't want to use the default CSS styling, you can delete the code from the index.css file. Okay, with this information, let's create our own custom component. I'll name this component as navbar, which will have a header tag h2. Now, to use this component, we write the component name between the JSX tags, just like an HTML element. And there you have it. Our component is now visible on the page. We can also move this code to a separate file. I can create a file by name navbar.jsx and move the code in this file. Once again, I'll export the navbar component so other files can use it. In app.jsx, I'll have to import this file in order to use navbar component. The navbar content is again visible on the page. It is important to note that component can only return a single element. So if I want to add a h1 tag in this code, it will result in an error. This is because it expects us to have only one topmost element. To solve this, I can wrap the code in an element like, for example, a div. But this will add an unwanted div which I really don't require. In this case, we can wrap this code in something called as React fragment, like this. Now, if I inspect the code, we don't find the div, and the error is also resolved. Next, I want to talk about JSX Expressions. With this, we can add dynamic content in our app using the curly brackets. You can add dynamic values, expressions, or variables in JSX. So, I can add an expression like this, or declare a variable and use it in curly brackets like this. Next, we look at an important concept in React called props. Imagine if our app has a list of products and we want to display these products using a card component. All the products will have an image, name, and price properties, for example. Let's right-click on the source file and create a file named card.jsx, which will contain this component. I will declare a function name card with the first letter as capital. To keep it simple, I'll declare a product name and a price. Let's export this and open the app.jsx to import the card component. The product name and price shows up on the browser. Since we are calling the card component from app.jsx, app becomes the parent component and card becomes the child component. Let's say I have 3 products. So I can just write the card component 3 times. Now, the problem with this code is we have 3 cards with the same content. Not very useful, right? To make it unique, we need a way to pass some data from the parent component, that is app, to the child component. This is where props come in. Props, short for properties, are a way of passing data from a parent component to a child component. With props, we can pass the values like this to the child component. Inside child component, these props can be accessed using the props object. In the card component, the name and price props are accessed using props.name and props.price respectively. Let's modify the code. In the app component, I'll add all the 3 product names and prices. In the child component, I'll add props parameter and replace the hard-coded text with props. There you have it. We now have 3 cards with unique data. You can also use destructuring like this. Ignore the styling for the moment. I want to refactor this code by storing the product's information in an array and looping through it using the map method. In React, when rendering a list of elements using map, each rendered element must have a unique key property assigned to it. The key prop helps React identify which items have been changed, added, or removed. So let's modify our code with this information. With these changes, the content on the page should remain unchanged. Now let's look at how event handling is taken care in React. To understand this, let's look at how JavaScript does it. Here, we usually select the element on which we want to add event listener and provide a callback function to perform the action needed. For example, I have selected a button with my button ID and added a click event listener which simply displays a message button clicked when we click it. But in React, we can register event handlers directly in JSX by using camel case event names. For example, onClick, onChange, onSubmit, and so on. So the code in React will look something like this. Using onClick, we call the handleClick function, which in this case is logging a message. You can also write inline code like this, where we are making use of an arrow function. Let's see this in action. Now, you can see the button click text getting displayed on the console. After event handling, I want to discuss another important concept in React called state. State is what allows React components to have dynamic behavior. A component can change due to interactions like button click, checkbox toggle, and so on, which leads to re-rendering components and displaying the updated content on the page. In React, state refers to an object that allows components to maintain and update data over time. And to manage the state, we make use of something called as useState hook. It takes one argument, which is the initial state value, and returns an array containing two elements, the current state value and a function to update that state value. To illustrate the use of state and useState, I'll take the classic example of count button, which increments the count every time the button is clicked. Let's create a new file, counter.jsx. To make use of useState, we will need to import it from the React package. Let's declare the function counter and add our useState hook with countState variable and setCount function to update the count variable. The initial value is set to 0. In JSX code, I'll have a button which displays the count. Using onClick, I'll call a function called increment. Let's declare this function that simply updates our state by calling the setState function with a new count value incremented by 1. Finally, we will export this and import it in the app.jsx file. Let me clean up this file first. Let's open the browser and check if the button is working. When you click the button, the count increases. So the way this works is, useState is used to initialize the count state variable with an initial value of 0. And the increment function updates the count state when the button is clicked, causing the component to re-render with the updated count value. To summarize, when the button is clicked, increment function is called, which contains the state setter function setCount that takes new count value incremented by 1, and the component re-renders. This is how we can make use of state in React to update the component to re-render and reflect the changes in the UI. Now, what if we want to take some action when our component renders or re-renders? Suppose if we have operations that happens outside of the component cycle, like fetching data from an API or DOM changes outside of React. Operations like these are called as side effects in React. In React, we have a hook called useEffect that allows you to perform side effects in components. It takes two arguments, a function and an optional dependency array. Let's consider the same example of counter component. We will add useEffect to this code. First, we'll need to import it. Next, let's declare useEffect and a function inside it. I'll simply log a message here. With this, every time I click the count button, the component re-renders and function inside the useEffect gets called. Now you will see this message twice. This is because of how React behaves in the development mode. But you won't see this happening in production, so we can ignore it. Now, let's add another state, say count2, that will increment the count by 2. It will also have a function that increments count by 2 every time the button is clicked. Whether I click the count or count2 button, the useEffect code will run because both the changes re-renders the components. But if I want the useEffect to run only when, say, count is clicked but not count2 button, then I can add this dependency using the second argument. I'll have an array with count. Now, if I click the button count, it consoles the message, but if I click the second button, it will not log the message. This is how you can add dependency to useEffect. If you want to run it only on the initial render of the component, you can simply specify an empty array. This will run only once and not on every re-render. So if I refresh the page, I can see the log message. But when I click the button, we no longer see the messages being displayed. With this information, let's look at how to use useEffect to fetch data from an API. Before moving ahead, let's recall what useEffect in React is. useEffect allows you to perform side effects in components. It takes two arguments, a function and an optional dependency array. If you do not provide the second argument, the side effect function will run on every render and re-render of the components. If you specify a dependency, it will run when the dependency changes. And if you pass an empty array, it will only run once after the initial render. So, if I want to call an API that fetches the data in the initial node, I can make use of the third option. My code will look something like this. I can have a getData function which fetches the data from the API once after the initial render. To see it in action, we will be making use of the Jikan API, which is an open source anime API. Also, I want to build a mini project that will use all the concepts that we have learned so far. So, let's quickly recap all the concepts we have learned so far. We started our journey by installing React application using Vite. Next, we looked at how to write HTML-like code using JavaScript XML. We also looked at what components are and how to use them in React. To pass data from parent to child component, we made use of props. We also looked at how React handles events. Then, we understood states and worked with useState to manage state. And finally, we looked at useEffect. Now, we'll be building a simple project that will make use of all the concepts that we have learned so far. Let's look at the project we are going to build. It will be a simple anime search application that will search the animes by name. For example, if I search for Dragon Ball Z, it will display the images related to it. Similarly, if I search for another anime, say One Punch Man, I should be able to see the images related to this anime. As I've already mentioned, we are going to use external API, Jikan, to fetch the data. To make our life easy, I have provided a gist of all the CSS styling we'll be using in the description below. The CSS code will be in the index.css file. So you can simply copy the code and paste it in the index.css. This way, you can use the CSS classes directly without having to worry about styling. Okay, I no longer require this counter component, so let me delete it. We will return an h1 tag under React fragment which says anime search. You should see this tag with some styling already applied. All these stylings are from the index.css file. I want to have an input tag where user can enter the anime name for searching. We will also add a button. So let's add the code. I will make use of div with a class name container. Make sure you are entering class name and not class because we are working in JSX. Okay, so our input tag and button is showing up. Next, Let's create a function that takes a name and fetches the data from Jikan API. This will be an async await function. Let's copy the API URL. You can find this URL in the description below. To test if we are able to fetch the data, I'll console the output. Now let's call this function. To do this, we'll be using the useEffect because we want to get this data on the initial page load. So let's do that. This will call the getAnime function. I want Naruto to load first. Also, let's add empty array as dependency so that fetched is called only once during the initial rendering of component. I have misspelled const, so let me correct this. And also I don't want the counter component, so I'll delete it. Let's check the console to see if we are getting the data. Yes, we have fetched the content successfully. I am interested in the data key which contains array of data we want. So let's update the code. Okay, so we have array containing the anime data. Notice we are not using the name parameter, so let's change the code to use it. Now I want to store the data received from the API in a state so that we can use it to render our component. So let's import useState and create a state and name it animes. Initial value will be an empty array. Now I'll remove the console statement and use the setAnimes function. Let's display the content in a container div. We'll have an anime card component that displays the content. We have not created this component, so let's declare it in a separate file. Right-click the source file and create a new file with name animecard.jsx. We'll create the function animecard, which will return a h2 tag for now. Import the file in app.jsx. To display the data, we'll need to loop through the animes data using map. If animes.length is greater than 0, we will display the content. Else, we will display some message like no result found. Now, we are able to see anime card getting displayed multiple times. Let's include the data received from the API in the anime card module. We will pass the anime in the anime card component. Let's declare props. We will use destructuring to get the anime. Now, let's add the image received from the API. I'll inspect the API data and check where the image location is. That's strange, I don't see a log message here. Oh, I had removed it. So let me add it back. It's in images, JPG, image URL. So let's update the image source. I want to see if this works. And there you have it. All the images are being displayed. Wonderful. Now, if I enter some text in the input and click the search button, it should search using the API and display the results. At the moment, when you click the button, nothing happens because we have not implemented this feature. So let's jump into it. I'll declare another state term, which will be the user input that can be passed to the API. The default value will be an empty array, or maybe let's have Naruto as default value. We'll set the value of input to term. Also, on change event, I want the term to get updated with the latest value. To do this, I'll make use of event to capture the value. Next, on click of button, I want the data to be fetched from the API. This is simple. Using the onClick, I'll just call our getAnime function with the query term. Okay, so let's see if this is working. Let's type Dragon Ball Z. And there you have it. Let me just search for another term, maybe One Punch Man. As you can see, we are now able to search and display the content from an API. That is it, guys. Hope you have enjoyed this crash course on basics of React. Thank you for watching and see you in the next video.